Hello students, welcome in this video lecture series on analog circuits and design 1. Instead I must say welcome to the department as you have finished your first year engineering and entered into the second year. So this is the first interaction with the department for you people. Alright. So you will face 5 subjects in this semester, and out of these 5 subjects, one subject is analog circuits and design 1, and I, Mr. PC Dhanavade, supposed to teach you this subject in the semester. So as I told you that you people were part of general engineering student, that is what your first year, and this is the first introduction of you people to the electronics and telecommunication department. So as you have done with your first year, it means 25% of your engineering is done. Right? So 25% of engineering is done. It means correlate this with the electronics and telecommunication engineering. See, in your first year of engineering, you have studied electronic components, and now by using those components, you need to build a circuit in a second year. Then after that, in second year, in third year, you will configure those circuits whatever you have studied in second year, and then you will have a system with you. Let us understand this 4-year engineering, that is 4 years of electronics and telecommunication engineering in detail. So let's start with the whiteboard, and then I think you will understand with the whiteboard. It's better to use it. So let's let's switch over to the board here. So total 4 years are there for the engineering, and now you're done with first year. See, in first year, what you have learned? In first year, you have learned about components. I'm talking about electronic components. So if I connect all those components, then it becomes a circuit. As I connect all those components, it becomes a circuit. That circuit analysis and design you will study in second year. See, engineering is moving step by step. In first year, only component study is there. You might have remember you have studied diode, then capacitor, resistors. See, only components you have studied. In second year, whatever components or few circuits that you have studied, now it's time to analyze and design those circuits. So configuration or connection of component is a circuit. That is what your second year study. Now as you switch towards third year, look at this, in third year, you will face a system. Means whatever circuits you have studied, connect those circuits, it becomes a system. Configure those circuits, it becomes a system. So system design and system analysis is a part of third year. Right? Now in final year, that is in the last year, see whatever systems you have studied, connect all those systems together, and then it becomes a product. That is what generally people call it as a project that you need to complete in final year. This is what 4 years of your engineering in electronics and telecommunication. Now see, in circuit, the network analysis is the subject and the ACD is the subject where you will study complete core circuits as well as components also. So out of these 2 subjects, I'm handling one of them, that is analog circuits and design 1. See, I'm saying ACD 1 means ACD 2 will be there, but it is in the next semester. Now, instead of wasting time, let's start with what is there in ACD 1. Let's take another page and start with ACD 1. So let me write here ACD 1. It is ACD 1. Now, in ACD1, the first thing that we are going to start with is power supply. That is power supply. Basically, it's a DC power supply. Now, what is DC power supply? See, in your first year lab also, you have seen some a box which gives you a DC voltage and DC current. What's the input for the box? The input for the box is 230 volt AC, that is line voltage. Is it? So henceforth, whenever I say line voltage, by default you understand that I am talking about this 230 volt AC, which is available at our home. Okay. So this line voltage is converted into DC voltage. And that the equipment or the device which converts that is called power supply. So what is the output of power supply? It is a constant DC voltage. So in first two chapters we will discuss about constant power supply, or we can say constant DC power supply, or to be more technical it is regulated DC power supply. So as let's start with what is that power supply. Well, look at this. Let me draw a block diagram of power supply. In power supply, first thing that we need to study is rectifier. This rectifier thing is not new for you people. You have studied in your 11 and 12, and even in first year you have gone to this rectifier. Now after rectifier, what is the next block? Next block is filters. The next block is filter. Even that filter thing is also not new. I know that. Is it? So you have studied rectifiers and filters theoretically. Here in second year, the difference is now we have to analyze those rectifiers, filters, and we have to design those rectifier filters. Then third block from this power supply chain is a regulator. Is what? A regulator. And at the output of regulator, I will get constant DC voltage. At the output, I am getting constant DC voltage. As if now, what is the input for this rectifier? See, the input for the rectifier is, let me draw a transformer here. And now this transformer is also not a new component that you are not aware with or something. This is an input. And what is the input for the power transformer? It is 230 volt AC. Let me write the frequency, that is 50 Hz. So 230 volt AC, 50 Hz is the input for this transformer. And now transformer's output is connected to the rectifier. Output of the rectifier is connected to the filter, output of the filter is connected to the regulator, and finally I am getting constant DC voltage. So as if I am getting constant DC voltage at the output, this complete chain, the complete power supply is divided into two chapters of your syllabus. See, the first chapter is this, only rectifiers and filters. What it is called? It is called unregulated power supply. And this thing, regulator, is included as a second chapter. And what it is called? It is called regulated power supply. So we will understand the difference between unregulated power supply and regulated power supply. So unregulated means still there are fluctuations in the DC voltage, and if I remove those fluctuations or variations, it becomes a regulated power supply. Now, how to remove that fluctuation is a part of regulator, and how to convert the AC signal, that is what, 230 volt AC, this, is it? How to convert this complete 230 volt AC into the fluctuating DC is a part of your first chapter, that is unregulated power supply. The circuit diagram, the waveforms, everything is known. I know that it was there in your first year syllabus. But still, we will go into the detail of each and every component which is used in a rectifier as well as filter. As if we have started with this chain of power supply, and the motto is we need to understand how this 230 volt large AC voltage is converted into a small DC voltage. And let's start with the first component, that is transformer. Let's start with first, that is transformer. Let me take a new page and we'll start with transformer. So let me draw a transformer. Look at this is a transformer. Intentionally I am drawing a step down transformer because henceforth everywhere we will use a step down transformer. I'll tell you what is the step down transformer and what is the step up transformer. Here at the input side it is 230 volt AC with frequency of 50 Hz. See, India uses 50 Hz frequency. Sometime I will tell you why India is using 50 Hz and why other countries or some European countries, even US uses 60 Hz, but India stick to 50 Hz. Meanwhile, whenever I get some time, definitely I will tell you the history of that 50 Hz frequency, is it? Now, let's start with this 230 volt AC. And here, what I am getting here also I am getting AC voltage. Here also I am getting AC voltage. But the amount of AC voltage which is present here is quite less than this 230 volt. So this thing is called primary and this thing is called secondary. And let me call number of turns at the primary is N1 and number of turns at the secondary is N2. Now whether the transformer is step up or step down is dependent upon the number of turns in primary and number of turns in secondary. So if number of turns in primary, that is N1, if that N1 is greater than N2, eventually one can say N2 is less than N1, then it is step down transformer. And if number of turns in the primary, that is N1, is less than number of turns in the secondary, that is N2, then the transformer is of type step up transformer. Now look at here, number of turns in the secondary, whatever I have drawn. Here, number of turns in the secondary is less as compared to the number of turns in primary, and that's why the secondary voltage is less than primary voltage, and hence it is a step down transformer. Let me write it here. It is a step down transformer. Right. So if you see power supply, generally in our lab also we have a power supply which gives output voltage from 0 volt to 20, at the max 25 volt. 25 volt DC. So that 230 volt has to be converted into small DC voltage. Small DC voltage is my requirement. Why small DC voltage is my requirement? Because all electronic equipment or gadgets work on very small DC voltage. So this 230 has to be converted into small DC, as the voltage which is available at the output is small. I need to down convert that 230 volt. That's why I am using step down transformer all the time. So basically it is a transformation from AC to AC, but the amount of AC voltage is reduced. Otherwise, voltage at the primary is also AC, voltage at the secondary is also AC. Both are AC voltages. As a, after the power supply, it will be converted into DC. That is the job of power supply, that convert AC voltage into DC. Now again, some of people from your class, uh, they don't understand the clear difference between AC and DC, because meanwhile in education they go on through some circuits which are wave shaping circuits that will be coming after 2-3 chapters. There is a confusion between AC voltage and DC voltage. There's always confusion. So let me clear the confusion here itself. What is AC and what is DC? So here somewhere at the corner, let me tell you what is AC and DC. Look at this. Whenever I say AC, what is the image or what is the signal that come in front of your eyes is this signal, a positive half cycle and a negative half cycle. This is the actual signal you imagine whenever I say AC voltage. Is it? And like this, whenever I say DC voltage, all of you imagine this as a DC voltage. Look at this. Because this is a standard AC and this is a standard DC. This line is a reference line, zero line, or you can say a ground line. Look at this. A ground line. Now, what is the difference between AC and DC? For any signal, you clearly take any means what? Any means anything. See, even if you take a noise signal like this, you will identify, or the seer or the equipment will identify this signal or categorize this signal either AC or DC. Because the seer or the equipment, which is digital one, which understands only two languages, either the signal is AC or the signal is DC. Now, how this equipment or devices clearly understand what is DC signal or which one is AC signal? They differentiate AC and DC on the basis of average value. Average value of a signal. For example, if look at this, in this AC signal, average value of the signal is 0. Look at this, positive half cycle and negative half cycle. Both are of the same magnitude with respect to time. So this positive half cycle can cancel negative half cycle. So as if positive half cycle is going to cancel negative half cycle, it means average value for the signal is 0. Look at this DC signal. There is only positive part. Look at this. This is a positive part. There is no signal in the negative part. If this is y-axis I am considering, then this is positive axis. Generally, we call it as, and this is what negative axis. So signal is present only in the positive part, and there is no signal in the negative part. So average value of this signal is non-zero, which is not equals to 0. And that's why it is a DC signal. Is it? Now, let me define. For any signal, if its average value is equals to 0, then the signal is AC. If its average value is not equals to 0, then it's a DC signal. Is it? So basically we are differentiating on the basis of average value. If average value is 0, it's AC. Average value is not equals to 0, it is DC. See, I am telling you average value is not equals to 0. It means it can be positive, any positive value, or it can be negative, any negative value. Now observe this sample signal, that noise signal that I have drawn, this one I am talking about. Now here, signal is present in positive area only. So average value of this signal is always positive. And what is our criteria? Our criteria is if the signal value is not equal to 0, then it is DC. Now see, value is positive, it means it is non-zero, it means the signal is DC. Let me give you another example. Now here also, see, I have a large positive half cycle and very small negative half cycle. Now can you judge whether the signal is AC or DC? Yes, find out average value. We are not going to find actual average value of the signal because it is just a sample random signal that I have drawn here. But by observation, I can tell you that this positive half cycle is not equals to negative half cycle as with respect to time. And look at the area. It means for that signal also, average value is not equals to 0. So if average value is not equals to 0, let me write here. Average value is not equals to 0. As if average value is not equals to 0, it means it is a, yes, it is a DC signal. Clear? Take another example. Let me draw another random signal. Here, where is the mouse? Yes, here it is. Now, in my case, very small positive half cycle, but it is a large negative half cycle. Now look at this. Here also positive half cycle, negative half cycle. Both half cycles are present. But what about the average value? Average value of the complete signal, including positive as well as negative, is it? Average value of a complete signal is negative. Is it? By common sense, I can tell you that average value is negative. As if average value is negative, it means it is non-zero. It is non-zero, it means the signal is DC. Good. Okay, let me draw another signal. Here I have look at this signal. Now here see positive half cycle can cancel negative half cycle. It means the average value of a complete signal is equals to 0. The signal is AC. So that is the basic difference between AC signal and DC signal. Is it? So that was not the actual part. We moved towards this part, this point, just because I want to tell you the difference between AC and DC. Now, what is the major part? Major part is to understand transformer. Now, come towards the transformer again. Now, what is there at the transformer? Primary as well as secondary. N1 and N2 are the number of turns in primary as well as secondary. Now, in some books, you will find a small dot at the primary somewhere here and at the secondary also here. What does it mean? It means if there is a positive half cycle at the primaries of the transformer, then same positive half cycle is available at the secondary. It means both primary and secondary are in phase. There is 0 degree phase shift. They are completely in phase. Sometimes you will find this dot here at the bottom. What does it mean? It means that, okay, let me rub the first one. Now, what does it mean? It means if there at the input side, if positive half cycle is there, then this positive half cycle is available at the bottom of the secondary. So, as if positive half cycle is available at the bottom, what is there at the top? At the top, I am getting negative half cycle. It means now primary and secondary are completely out of phase. These two terminals, this one and this one, are out of phase. That is 180 degree phase shift present between primary and secondary. So this is what dot convention. Dot follows the phase. That's what the conclusion. Dot follows the phase. If dot is at the upper side, then upper side is in phase with the primary. If dot is at the lower side, then lower side is in phase with the primary. That's what dot convention in the transformer is. Now, let me write another equation. Okay, let me write here related to the transformer that you're already aware with. N1 divided by N2 is equals to V1 divided by V2, which is equals to I2 divided by I1. What is that V1 and I1? V1 is the voltage at the primary, V2 is the voltage at the secondary, I2 is the current at the secondary, and I1 is the current at the primary. Now look at this equation. Number of turns ratio, that is N1 and N2. The ratio of N1 and N2 is in or proportional to the voltage as well as current. But look at the voltage and current. I am writing V1 by V2 is equals to I2 divided by I1. So those are out of phase with the current and voltages. So that is the most important equation. I know you are aware with this equation, but take it as a part of revision. N1 divided by N2 is V1 divided by V2 is equals to I2 divided by I1. This is the important equation related to number of turns for the primary as well as the secondary. Now, if you feel that much is okay about the transformer, then we can move towards the actual chapter from your syllabus, that is unregulated power supply. So as this transformer is a part of first part of your power supply, so that's why I started with this power supply initially. Now in next lecture, what we will do, in next lecture we will understand the measurement of transformer using multimeter as well as CRO. See, you are aware with multimeter, you have handled it, and even you know what is CRO. You have used that CRO in our lab. So multimeters and CRO is well known to you people. Now, if I want to measure the secondary voltage of the transformer using multimeter and using CRO, what is the difference between measurement of output voltage, that is secondary voltage, using CRO, and measurement of secondary voltage using multimeter? In next lecture, we will understand the measurement of secondary voltage by two different equipments or devices. Okay? So wait for next lecture, we will start with measurements. Thank you.